All right, welcome Methods students to the 1B video. This section we're looking at identifying and describing relations and functions. Again, something you would have seen in Year 11, so a bit of revision for you here. First definition, or first few definitions to get our head around, when we talk about a relation, we just mean any kind of connection between x and y. So a relation could be a set of ordered pairs, it could literally just be a set of coordinates. It might be an equation that involves x and y, or a rule. It could also be, when you're looking at a graph on the Cartesian plane, that is automatically a connection between x and y. So any information that connects x to y is called a relation, and the domain of a relation is the set of all possible x values for which the rule is defined. In other words, domain is the x values where the thing can exist, and range is the set of all possible y values generated by the rule given the possible x values. So we often think of like the x values as being what can be subbed in, the y values are what can come out of the rule. But ultimately, we just need to remember domain, we're talking x values, range, we're talking y values. Usually, if you have to find the range, 9 times out of 10, you'd be sketching a graph and then trying to identify it. In a lot of cases, you can work out the domain just by looking at the rule. But let's see some examples and hopefully it'll make sense as we go. So example 3 says, consider the relation defined by the rule y equals x squared minus 4. First thing we're asked to do is to sketch the graph. So let's quickly set up a x and y axis. We should hopefully remember what y equals x squared looks like. It's just our plain old parabola. Move it down 4 units and you get, I'm a bit rusty on my parabolas actually. You get that parabola there that sits at 0, -4. Now, if we just wanted to know the range, that's actually enough information. If we're going to sketch the graph properly, we might as well get into good habits and find the x-intercepts and label them. In methods, when you do graphs and label key points, you're supposed to label intercepts, turning points, but also label with coordinates. So let y equal 0, we get x squared take 4 equals 0, x squared equals 4, so of course x equals plus or minus 2. And as I said, get into good habits nice and early. We're going to label those points with coordinates. So there's our graph. What's the domain? The domain is all real numbers, because this graph just goes, it'll keep going to the left, it'll keep going to the right. So the domain is R. What is the range? The range, well, the y values, if we think sort of from bottom to top, because we give our intervals from lowest to highest. So the lowest y value on the graph is -4, and it does actually get to -4. So the range will start from -4 with a round bracket, excuse me. And the y values at both ends will just keep going up and up and up all the way to infinity. So the range is -4 to infinity. You could also write, you don't need to do it this way, but you could also write something like y is greater than or equal to -4 for the range. But that interval notation is probably the more common way of seeing the range written. All right, functions. So functions are pretty important. In fact, most of the graph types and rules that we study in methods will be functions, but the definition of a function is that it's a relation where every x value has only one possible y value. So in other words, if you sub in any x number, only one y number can come out. The easiest way to test whether something's a function is to actually have its graph and then use the vertical line test. And the idea is that any vertical line should only cut the graph once if the graph is a function. So for example, if you've got something like a parabola, if we look at example 4, no matter where I draw a vertical line on this graph, I can only ever make it cross the line at most once. There's no vertical line that would cross that graph twice, which means yes, this is a function. So state whether it's a function or not a function. This one is a function. Whereas here we have like an inverted parabola or an inverse parabola. Quite clearly, I can draw a vertical line that would cross the graph at 2 different points, which means there is an x value that has 2 different y values, and therefore that fails our vertical line test and is not a function. This one here looks probably like the graph of y equals x cubed. And so if we assume, and it is a bit of an assumption, but if we assume there's no turning point here, if we assume maybe this point at the origin is a point of inflection but not actually a turning point, then this would pass the vertical line test. No way that we can draw a line that sort of crosses twice, a vertical line that crosses twice there, so this one is a function. Okay, Some function notation. Important to remember in methods that there's actually quite a lot of different ways that they can just give you the equation or the rule for a function. You can see here just a few different examples where basically all these things are giving you a rule y equals 3x squared and giving you a domain, but they're written in quite a few different ways. So often it'll start off with sort of something like it'll introduce the function name like f. It'll then give you a domain, sometimes gives you this codomain, which doesn't really tell you any useful information. It just tells you that the y values can come from all real numbers, and then give you the rule. But again, you can see that this one here, the second one down's got, here's the equation first, and then given the domain afterwards, the domain of x is greater than or equal to 0. A couple of other different ways you can be given the function first and then the domain. This last one, probably the most common way you would see fully stated function notation, where it introduces the function name, it gives you the domain in interval notation, it then gives you a codomain, which again is not going to tell you much useful information, but just don't be distracted by it, where f of x, so it gives you then the rule at the end. So ultimately this is just saying the equation is y equals 3x squared, the domain is from 0 inclusive up to infinity. Okay. There's a little bit of extra sort of information here, which was already stated before. If you do see this shorthand, if you ever see sort of dom f, that's just shorthand for domain of f, and likewise ran f is just shorthand for the range of f. One of the reasons function notation is useful is because it allows us to kind of easily sub things in to the function without having to write statements like when x equals 5, what does y equal? So for the function, g of x equals x squared minus 2x, determine g of 5. That just means replace x with 5. In other words, sub x equals 5 into the function and see what happens. So we will get 5 squared minus 2 times 5, which of course is 25, take away 10, which is 15. The second one, determine g of a plus 1. Well, that looks a bit trickier, but it literally just means replace x with a plus 1. So g of a plus 1 would be a plus 1 squared, so replacing the first x, minus 2 times a plus 1. Now we probably could stop there, and it might depend on how the question's written as to whether we need to keep going. But we could also expand and collect some like terms. So let's do that. Remember that a plus 1 squared really means a plus 1 times a plus 1. So when we expand that properly, we're going to get 3 terms out of that. And I'm just going to put here minus 2a. So let's expand this one. Minus 2a and then minus 2. So this here is a squared plus 1a plus another 1a plus 1 times 1 minus 2a minus 2. It's a bit squished. Just don't forget that. Sometimes people, especially if you haven't been practicing this for a little while, often people expand that bracket and just say, oh, it's a squared plus 1 squared. But there's also these 2a's in the middle here. So we've got a squared plus 2a plus 1 minus 2a minus 2. Collecting some like terms here, we've got a plus 2a and a minus 2a. We've also got a squared plus 1 take away 2. So this actually just becomes a squared minus 1 once expanded and simplified. And then, lucky last example, this one says, and it's a little bit funny the way this is written. So remember that the question said determine, so it's asking us to find something. Determine x such that g of x equals 0. So in other words, we want the whole function to equal 0, and then we want to solve for x. So we're going to, if we're letting g of x equal 0, we make the substitution on the other side, and we just say 0 equals x squared take away 2x. And we can solve that. That's a quadratic equation. There's a common factor, so we can take x as our common factor. And by the null factor law, we then get x equals 0 or x minus 2 equals 0. So x equals 0 is already an answer. And of course, add 2 to both sides there to get x equals 2. That takes us through exercise 1b. Have fun with your checklist questions.